February 1942. Java, Dutch East Indies. The B-17 Flying Fortress, serial number 41 to 2471, was supposed to be one of many in a long list of American bombers pounding enemy positions across the Pacific. Yet this particular plane, caught in the chaotic aftermath of the Battle of Java, found itself far from its intended course. With its engines sputtering and trailing smoke, the aircraft struggled against the forces of gravity as it made an emergency landing on a jungle-clad airstrip. The men who had piloted the Flying Fortress were either dead or captured, and the aircraft, though battered and scarred, had survived. The scene on the ground was one of stark contrast, the heavy, powerful silhouette of the B-17 against the delicate greenery of Java's dense jungle. Japanese forces, still reeling from their own setbacks in the region, wasted no time in securing the plane. Soldiers, armed and vigilant, surrounded the wreckage. The thick air was punctuated by the clatter of boots on the dirt as the Japanese troops moved in, taking inventory of their unexpected prize. The aircraft's crew had been fighting a desperate battle in the sky. A handful of B-17 seconds, far from their base and with limited support, had been dispatched to protect the area. They had fought valiantly, but against the overwhelming Japanese forces, survival had been a mere stroke of luck. 41 to 2471 had been one of the few to remain airborne after the battle. Its capture wasn't just a stroke of fortune, it was a game-changer. To the Japanese engineers, this aircraft was more than a captured enemy. It was a symbol of American industrial might that they had not fully understood until that moment. As the men disembarked from their positions and approached the bomber, the sheer size and complexity of the B-17 began to sink in. Standing in front of the massive aircraft, its wings stretched wide against the sky, the engineers marveled at its sturdy construction. This was not just a plane, it was a testament to the industrial power of the United States, a machine built for one purpose: to dominate the skies. Yet here it was, grounded, its secrets ripe for discovery. The Japanese soldiers quickly moved to inspect the interior, noting the heavy machinery, the reinforced bomb bays, and the seemingly endless array of interconnected systems. It was clear this aircraft was something unlike anything Japan had produced. The precision of its design, the quality of its components, and its almost intimidating scale stood in sharp contrast to the handcrafted nature of Japanese aircraft production. It was evident that this was not just an ordinary bomber, but a product of systematic large-scale manufacturing, a feature the Japanese military could not afford to ignore. Within hours, orders were given to transport the bomber from the airstrip to a more secure facility. The engineers at Tachikawa Airfield were waiting. These men, trained in the delicate art of aircraft engineering, had seen countless designs in their careers. But nothing had prepared them for the revelation that was about to unfold. What they didn't yet know was that this captured B-17 would expose the limitations of Japan's war machine, and in doing so shift the course of their understanding of modern warfare forever. The B-17 was loaded onto a transport truck, the once pristine paint now weathered by battle, and driven to a research facility known as the Giken Air Technical Research Institute. The journey was long and silent, the only sounds the rumble of the truck and the rustling of the jungle surrounding them. The aircraft, now a trophy of war, was treated with the reverence due to something both alien and extraordinary. As it arrived at the facility, it would be dismantled and studied meticulously. For Major Kazuyuki Saito, who was tasked with overseeing the examination, the arrival of the B-17 signaled not just a moment of tactical importance but one of industrial reflection. He had spent years working within Japan's military-industrial complex. But the stark difference between the production methods of the United States and Japan was becoming increasingly clear. Japan's own planes were meticulously handcrafted by skilled artisans. Each component was built with care, but also with immense human labor. Now in front of him lay the B-17, a symbol of a different approach, a machine that could be mass-produced, a design built on standardization, not on the craftsman's hand. As the team of engineers began their work, Saito stood back, taking in the sight of the B-17. It was a work of both form and function, its parts designed to be interchangeable, its assembly process efficient and automated. For the Japanese engineers who had to rely on labor-intensive methods, It was a revelation. The bomber's fuselage wings and internal systems were made from standardized components that allowed for rapid production at unprecedented scales. This wasn't just about making a better plane. It was about making it faster, more efficiently, and at a scale that Japan simply could not match. Inside the facility, the B-17 was carefully taken apart piece by piece. Each system was studied in detail: its engines, its electrical wiring, its hydraulics, and its bomb release mechanism. The engineers marveled at how every part seemed to fit perfectly into place, as though each component was designed to be manufactured in mass quantities rather than one-off custom pieces. It wasn't just the bomber's design that caught their attention. It was the way the Americans had figured out how to mass-produce it. The engineers took careful notes documenting everything. Every rivet, every joint, every panel, and every piece of the aircraft was scrutinized. The work was meticulous, methodical, and would lay the foundation for a shift in Japan's own industrial approach. At that moment, as Saito and his team examined the inner workings of the B-17, the realization began to dawn. America's real power wasn't in superior craftsmanship. It was in their ability to create systems of mass production that could outpace Japan's capacity for labor-intensive manufacturing. The implications of this discovery would echo far beyond the walls of the Giken Air Technical Research Institute. Japan's own post-war industrial revolution would be shaped by this very understanding, as they too sought to harness the power of systematic mass production. But for now, in 1942, the engineers at Tachikawa could only stare in awe at the captured B-17. The bomber was not just a technological marvel, it was a sign that the rules of warfare had changed. And for the Japanese military, this was a harsh lesson in how the future of war would be fought. March 1942, Tachikawa Airfield, Japan. The team of engineers worked through the days and nights, their eyes fixed on the B-17 that sat in pieces around them. They had seen aircraft before, but nothing quite like this. It was not just a technical marvel, it was a revelation. As the engineers examined each part of the bomber, the weight of what they were discovering slowly began to settle in. They were looking at the future of warfare, a future built on the principles of industrialization and mass production ideas that Japan at the time could barely comprehend. The B-17 was designed with one overriding goal: efficiency. The bomber's construction was based on interchangeable parts, each one designed to fit seamlessly with the others. The aircraft's fuselage wings and internal components were not crafted with the meticulous attention to detail that Japanese planes were built with, but were instead created to be mass-produced quickly and reliably. Each piece of the B-17 could be manufactured in vast quantities, a stark contrast to Japan's reliance on skilled workers to handcraft every part of their own aircraft. As the engineers began to dig deeper into the bomber's systems, they noted the sophisticated nature of its assembly. The B-17 was not merely a sum of its parts, it was a product of American industry. Its design had been optimized for quick assembly, with every component standardized for mass production. The aircraft was built for the purpose of speed in production, speed in delivery, and speed in battle. This was not just an aircraft, it was a product of an industrial juggernaut. One of the most striking aspects of the bomber's design was the way its components were crafted to be interchangeable. Unlike the handmade components of Japanese aircraft, which required skilled labor and precision, the B-17's parts were designed to be assembled quickly and efficiently. It wasn't just the bomber's power that made it formidable, it was the speed with which it could be made, repaired, and deployed. This efficiency was something Japan had never achieved, and the more the engineers worked, the more they realized the scale of the gap between their own industry and that of the United States. At the same time, Saito and his team were faced with the growing realization that this was not just a technological discrepancy, it was an industrial divide. The United States had mastered a new kind of warfare, one that didn't rely on superior craftsmanship or individual genius. Instead, it relied on the relentless power of mass production, something that Japan's military-industrial complex simply couldn't match. The engineers had seen firsthand how the US could produce machines in unprecedented quantities. The Boeing factory in Seattle, where the B-17 seconds were manufactured, was capable of turning out 16 bombers per day at the height of production. This was no accident. This was the result of a carefully orchestrated system of production designed for efficiency, with every piece of the process fine-tuned to maximize output. The Japanese engineers, many of whom had worked on Japan's own aircraft, could only marvel at the sophistication of the American system. Their own factories were plagued by inefficiency, and the reliance on skilled labor made it difficult to scale production. The engineers had to rely on human expertise to fit each part together, a labor-intensive process that slowed down production and made repairs difficult. By contrast, the American system, embodied by the B-17, was a machine in itself, a system that could operate without the need for highly specialized craftsmen, allowing the U.S. to outproduce any adversary. The more the engineers studied the B-17, the more it became clear that Japan's industrial system was outdated. Japan's reliance on handcraftsmanship had made their aircraft some of the finest in the world, but it also made them vulnerable. In a war of attrition where numbers often meant more than quality, the ability to produce aircraft quickly and in large quantities was a game-changer. The Americans had figured out how to make war machines at a scale that Japan could not even fathom. Saito gathered his team one evening, his face drawn with the weight of their discoveries. They had expected to find flaws in the B-17 weaknesses they could exploit for Japan's advantage, but instead they had uncovered something far more daunting. The United States wasn't just fighting a war of superior technology, they were fighting a war of production. And in this war, Japan was hopelessly outmatched. But the B-17 wasn't just a symbol of American military might, it was also a glimpse into the future. The lessons learned from studying the bomber would reverberate throughout Japan's post-war industrial revolution. In the years to come, Japan would shift its focus, moving away from handcraftsmanship and embracing mass production techniques that would allow it to rise from the ashes of war and become an industrial powerhouse in its own right. As the engineers continued their work on the B-17, they began to realize the full extent of the lessons this aircraft had to offer. The B-17 was not just a symbol of America's strength, it was a harbinger of the new rules of warfare rules that would favor the side that could produce the most, the fastest, and the most efficiently. By the time the engineers had finished their examination of the bomber, it had become clear that the future of warfare was not about superior craftsmanship, it was about industrial might. And in this area, Japan had much to learn. The lessons from the B-17 would shape Japan's post-war recovery and help define the country's industrial capabilities for decades to come. April 1942, Tachikawa Airfield, Japan. As the final components of the B-17 were carefully examined, the enormity of the situation began to settle in. Saito stood back watching his team work, each engineer absorbed in their task, each piece of the aircraft being disassembled with precision. What they had uncovered wasn't just a technical marvel, it was a blueprint for a new way of thinking about warfare. The B-17 was not simply a product of ingenuity and superior engineering, it was the embodiment of the United States industrial strategy, and that strategy was something Japan could no longer afford to ignore. For weeks, the engineers had been unearthing one revelation after another. They had expected the B-17 to reveal weaknesses, to show flaws in American engineering that Japan's craftsmen could exploit. But instead it had exposed a startling truth: the U.S. wasn't relying on individual genius or craftsmanship. America had developed a system capable of mass-producing war machines at a scale Japan couldn't match. In fact, they were producing aircraft faster than Japan could destroy them. The most striking element of this realization was the concept of mass production. Unlike Japanese aircraft, which required skilled artisans to meticulously craft each component, the B-17 was constructed from standardized interchangeable parts. Its assembly line, built upon automated processes and efficient workflow, allowed the United States to scale its production capacity in a way Japan could not even imagine. The B-17 could be replicated quickly, repaired easily, and deployed at an unprecedented rate. In a small conference room at Tachikawa, Major Saito gathered his engineers for one last debrief. The room was filled with papers and diagrams, the result of months of meticulous study. Saito cleared his throat, addressing the team with a mixture of awe and frustration. "Do you see now?" he asked, his voice steady but laced with disbelief. "It's not about the individual skill of the craftsman. The Americans have created something else entirely. This system. This is how they will win." The engineers exchanged glances, each of them beginning to understand the depth of the challenge now facing their nation. Japan had prided itself on the quality of its work. Its planes were finely crafted, beautiful machines that could hold their own in battle. But as they looked at the B-17, they realized the true advantage lay not in superior craftsmanship, but in the ability to produce aircraft in mass quantities. The United States had figured out how to build war machines like factories produce consumer goods with minimal downtime and maximum efficiency. For Japan, this was a turning point. The team at Tachikawa could no longer deny that America's industrial capabilities were far beyond their reach. What the engineers had learned from the B-17 would haunt Japan's military planners for the rest of the war. They had been fighting with skill and ingenuity, but now they faced an enemy that could outproduce them at every turn. Saito's mind raced as he considered the implications of what they had uncovered. He had spent years studying military technology, but never had he encountered a system so vast, so well-oiled, and so relentless in its output. The United States wasn't just manufacturing aircraft, they were manufacturing an unstoppable force. The more Saito thought about it, the more certain he became. Japan could not win a war of attrition against the Americans. They could not compete with the sheer scale of U.S. production, and they could not afford to engage in a battle where quantity mattered more than quality. The B-17, with its flawless assembly, had exposed this fact more clearly than any report or piece of intelligence ever could. In the months to come, the engineers at Tachikawa would continue their work on the captured B-17 seconds, but their focus began to shift. They had learned all they could about the aircraft itself, but now the real challenge was how to counter the U.S. production system. Japan's efforts to match America's industrial output would be the heart of the nation's war strategy moving forward. The realization that mass production, not superior craftsmanship, was the key to success in modern warfare would lead Japan to rethink its entire approach to military production. In the meantime, the captured B-17 seconds were slowly disassembled, studied, and ultimately used as models for Japanese engineers attempting to improve their own aircraft. But the engineers knew that it wasn't enough to copy the Americans' designs. They had to rethink the very foundation of their own industrial processes. What they needed was not just better aircraft, but a better way to build them faster, cheaper, and in larger numbers. Saito's thoughts turned to the future. As Japan moved further into the war, the lessons of the B-17 would reverberate throughout the military-industrial complex. In the coming years, Japan would attempt to adopt more efficient production methods, striving to match the scale of American manufacturing. But it would be a long and difficult road. The B-17 had exposed the truth. Japan's ability to produce war machines in the quantities needed to win the war had been outclassed. The Industrial Revolution that had fueled America's rise as a global power was now a force Japan could not defeat through craftsmanship alone. This realization marked the beginning of a new chapter for Japan's war effort. A chapter focused not on the quality of the machines they produced, but on their ability to replicate them in the thousands. But by the time Japan would begin to shift its industrial strategy, the tide of war would have already turned. Summer 1942, Japan. As Japan's military-industrial complex grappled with the revelations brought by the captured B-17 seconds, the full weight of the challenge they faced became clearer. The engineers, who had once been celebrated for their craftsmanship and innovation, were now forced to confront a stark truth. America's industrial capabilities were far beyond their own. The United States had achieved an unprecedented scale of war production, and Japan, despite its early successes, was falling behind. The B-17 was no longer just a captured bomber. It had become a symbol of everything that Japan lacked. As Saito and his team continued their examination of the aircraft, they couldn't escape the realization that the U.S. had mastered the art of mass production in ways that Japan had yet to understand. This shift in focus from craftsmanship to industrial output marked a turning point in Japan's wartime strategy. The engineers at Tachikawa began to ask themselves how they could adapt. Could Japan, with its limited resources, find a way to replicate the efficiency of America's production lines? The question was not just about creating better aircraft or more powerful weapons. It was about creating a system that could match the speed and scale of American manufacturing. At the heart of this challenge was the issue of labor. Japan's reliance on skilled workers to craft each component of its aircraft had been a point of pride, but now it was a liability. The process was slow, labor-intensive, and ultimately unsustainable. In contrast, the Americans had developed a system where workers could specialize in specific tasks and machines could assist in the production of parts. The use of standardized interchangeable components meant that fewer skilled workers were required, and production could proceed more quickly and with greater consistency. Saito knew that Japan would need to radically overhaul its own manufacturing processes if it was to have any hope of competing. The country had already begun to shift its focus toward producing larger quantities of military equipment, but the scale of that effort was far smaller than what the U.S. could achieve. Still, the captured B-17 seconds provided a starting point. By studying the American bomber's design and assembly methods, Japan's engineers could begin to imagine what their own future might look like, a future where mass production would drive the war effort. The impact of the B-17's capture extended beyond the technical sphere. As Japan's military leaders saw the shift in industrial priorities, they understood that the war was no longer just about superior tactics or technology. The U.S. had entered a new phase of warfare, one where the true strength of a nation lay in its ability to produce weapons and machines at an industrial scale. This understanding would forever change Japan's approach to the conflict and would influence the way the country would rebuild after the war. In the years that followed, Japan began to experiment with its own forms of mass production. The country would never be able to match the scale of American industry, but they would try to adapt elements of the American system to their own needs. It was a difficult process, one that would take time, resources, and a willingness to embrace a new way of thinking about production. But the lessons learned from the B-17 would help guide Japan's post-war economic recovery, allowing the country to emerge from the devastation of war and become an industrial powerhouse in its own right. Yet, even as Japan worked to catch up, the impact of the B-17's design and the lessons learned from its examination would continue to haunt them. In the final years of the war, Japan was already fighting a losing battle in terms of industrial production. The U.S. was churning out aircraft, tanks, and ships faster than Japan could even begin to replace its losses. The scale of America's production was simply too much for Japan's industry to keep pace with. As the war dragged on, the Japanese military found itself overwhelmed by the sheer volume of American weapons and equipment flooding the Pacific theater. The mass production system that had been introduced by the United States was a key factor in their eventual victory. While Japan's aircraft were still technologically superior in many respects, they could not match the relentless output of American factories. In the end, the lessons of the B-17 were not just technical, they were a testament to the new realities of modern warfare. Mass production had become the defining factor in determining which nation would dominate the skies, the seas, and the land. And while Japan would never be able to fully replicate the American model, the captured B-17 had opened their eyes to a new form of warfare, one where the speed of production was as important as the quality of the weapon itself. August 1945. Japan. As the war reached its brutal conclusion, Japan found itself on the brink of collapse. The lessons learned from the captured B-17 were clear, but they came too late. Despite their best efforts to adopt some of the production techniques seen in the American bombers, Japan's industrial capacity could not keep pace with the scale of the war machine the U.S. had built. The massive American production lines, which had been churning out war machines at a staggering rate, ensured that the Allies held an insurmountable advantage in terms of both numbers and technological innovation. By 1945, Japan's military-industrial complex was under immense strain. Allied bombers had decimated key industrial hubs, leaving Japan with limited resources to manufacture even the most essential war equipment. The B-17 seconds, which had once been the focal point of Japanese engineers' attention, now seemed like a distant memory, an impossible dream of what could have been. The realization that mass production had become the backbone of modern warfare had arrived too late to alter Japan's fate. Even as Japan struggled to rebuild its war effort in the wake of the relentless Allied bombardments, the legacy of the B-17 was already beginning to shape the future. The engineers at Tachikawa and other research facilities had come to understand that industrial warfare was no longer won on the battlefield with superior tactics or skill alone. It was won in the factories where machines could be replicated and replaced faster than they could be destroyed. The US had demonstrated the power of mass production with a vengeance. Boeing's Seattle plant had produced thousands of B-17 seconds along with countless other warplanes, tanks, and ships. While Japan had focused on perfecting each piece of equipment with painstaking craftsmanship, the U.S. had perfected the art of efficiency, producing more machines faster and cheaper, and with a remarkable degree of interchangeability. In the aftermath of Japan's defeat, the country was left to pick up the pieces of a shattered economy. The war had destroyed not only Japan's cities, but also its industrial base. Yet the lessons learned from studying the B-17 would not be forgotten. Japan's post-war recovery would be built on a foundation of mass production, a concept that had been embraced by the engineers who had studied the American bombers in the closing years of the war. In the 1,950 seconds and 1,960 seconds, as Japan's economy began its remarkable rise, many of the principles that had been uncovered in the study of the B-17 were applied to the country's industrial sector. The shift toward mass production that had been introduced during the war would become the cornerstone of Japan's post-war economic miracle. Companies like Toyota, Sony, and Honda would adopt assembly line techniques and standardized manufacturing processes, eventually becoming global leaders in their respective industries. But despite the successes of Japan's post-war industrial revolution, the shadow of the B-17's lessons remained. The engineers who had studied the American bomber had witnessed firsthand the power of a system that could produce in quantities Japan could never match. It was a sobering reminder that in modern warfare, quantity often triumphed over quality, and it was a lesson that Japan would carry with it as it rebuilt itself in the decades that followed. The war had ended, but the effects of the B-17's capture and study would echo far beyond the immediate conflict. The United States had not only defeated Japan on the battlefield, it had reshaped the very nature of modern warfare, showing that the true power of war machines lay not in the quality of the individual components, but in the ability to produce them at an industrial scale. In the years following the war, Japan would come to understand the full implications of this shift. The country's industrial base would eventually rival the world's best, but it was clear that the American model of mass production had set the standard. And while Japan would never fully replicate the American system, the lessons learned from the B-17's capture and study would serve as a guidepost for its future development. By 1945, the war was over, but the world had irrevocably changed. The age of mass production was upon them, and both the U.S. and Japan would carry forward its legacy. For Japan, the lessons learned too late in the war would ultimately lay the foundation for a new era, one where manufacturing power would define the future long after the war itself had ended.